Welcome to SciCuriousID, where we delve into the mysteries of our planet. Today, we're exploring one of Earth's most formidable natural phenomena. SciCuriousID presents the immense energy that was once distributed and spread throughout the entire deep water column is now forcefully squeezed upwards into a much shallower space. This compression causes the wavelength to dramatically shorten, while simultaneously, the wave's height rapidly and significantly rises. This profound transformation culminates in the wave morphing into a towering, destructive wall of water, ready to unleash its fury upon the land. How is it possible that a seemingly subtle, singular movement deep beneath the vast expanse of the ocean can unleash such an immense wall of water, capable of traversing entire oceans and bringing such widespread devastation?
Behind every question lies discovery. I'm Saluna, and this is SciCurious, where we uncover the science shaping our world.
The profound answer to this question is intricately woven into some of the most astonishing and fundamental principles of physics that govern our Earth. The vast majority of tsunamis originate far beneath the ocean's surface, in the deep abyssal plains where the colossal tectonic plates that form Earth's crust are in constant, albeit slow, motion. These immense plates relentlessly grind against each other, collide with unimaginable force, and under immense pressure, suddenly slip past one another in a dramatic geological event. When one of these massive tectonic plates abruptly shifts or thrusts upwards, it causes a significant and rapid displacement of the seafloor directly above it. Consequently, the colossal column of water, stretching from the ocean floor all the way to the surface, is also displaced with tremendous force, initiating the birth of a tsunami. To better understand this initial displacement, consider a simple analogy. It's much like pushing down on the bottom of a bathtub filled with water. The moment you apply pressure, the water within the tub instantly surges both upward and outward, creating ripples and waves. This illustrates the fundamental principle of how the ocean's water reacts to the sudden movement of the seafloor. This sudden and powerful movement of the seafloor launches a series of waves that carry an absolutely immense amount of energy. These waves then begin their journey, propagating horizontally across the vast expanse of the ocean, carrying the stored energy from the initial geological event. However, and this is a truly surprising aspect of tsunamis, when they are in the deep, open ocean, a tsunami wave may rise to a height of less than a single meter. This makes them virtually imperceptible and entirely invisible to passing ships, which would simply ride over the subtle swell without ever realizing the immense power lurking beneath. It's crucial to understand that a tsunami is not merely a singular, isolated wave. Instead, it is a complex and powerful train of waves, often stretching for hundreds of kilometers from one wave crest to the next. This vast wavelength is a key characteristic that differentiates tsunamis from ordinary surface waves. Because the immense energy of a tsunami propagates and moves through the entire depth of the ocean, from the surface all the way down to the seafloor, and not just confined to the surface like typical wind-generated waves, tsunamis exhibit fundamentally different behaviors and characteristics compared to normal ocean waves. In the vast, deep sea, these powerful waves can achieve astonishing speeds, traveling at up to 800 kilometers per hour. This incredible velocity is comparable to that of a modern passenger jet aircraft, yet, remarkably, they maintain their barely perceptible height, appearing almost flat against the immense expanse of the deep blue ocean. But as these incredibly fast, yet subtle, waves begin to approach and eventually reach the shallower coastal waters, a dramatic and profound transformation occurs. The dynamics of the wave fundamentally change, setting the stage for its destructive power. As the tsunami wave enters these shallower regions, the bottom portion of the wave begins to drag significantly against the seabed due to friction. This interaction causes the lower part of the wave to slow down considerably, while the upper part of the wave, still carrying its immense momentum, continues to move quickly, creating a critical differential in speed within the wave structure. The immense energy that was once distributed and spread throughout the entire deep water column is now forcefully squeezed upwards into a much shallower space. This compression causes the wavelength to dramatically shorten, while simultaneously, the wave's height rapidly and significantly rises. This profound transformation culminates in the wave morphing into a towering, destructive wall of water, ready to unleash its fury upon the land. This critical process is scientifically known as wave shoaling. It is precisely why the very same wave that can pass completely unnoticed and imperceptible in the vast, deep ocean can, upon reaching the shore, transform into a monstrous, towering wall of water, potentially reaching heights of 30 meters or more, unleashing catastrophic devastation. Unlike ordinary surf waves that typically curl and break with a foamy crest, a tsunami behaves very differently. It doesn't break in the conventional sense. Instead, it inundates the land like a rapidly rising tide, pushing immense walls of water and debris far inland, sometimes for many kilometers, causing widespread destruction. Here's a truly astonishing fact. The devastating 2004 Indian Ocean tsunami, one of the most powerful natural disasters in recorded history, released an amount of energy equivalent to approximately 23,000 atomic bombs. This staggering figure underscores the immense, almost incomprehensible power contained within these natural phenomena. This colossal wave raced across the vast Indian Ocean with incredible speed, covering immense distances in a remarkably short time. It reached the distant shores of Africa, nearly 5,000 kilometers away from its origin, in under 10 hours, demonstrating its relentless and rapid propagation across entire ocean basins. While earthquakes are the most common trigger for tsunamis, they are certainly not the only cause. Other powerful geological and extraterrestrial events can also generate these destructive waves. Underwater landslides, massive volcanic eruptions occurring beneath the sea, and even the catastrophic impact of an asteroid can all create tsunamis, each with varying degrees of intensity and destructive potential. Evidence suggests that some ancient megatsunamis reached truly unimaginable heights, potentially hundreds of meters tall. Such colossal waves would have possessed the power to completely erase entire coastlines, fundamentally altering the geography of regions and leaving behind indelible marks on the Earth's surface. Because tsunami wavelengths are extraordinarily long, they possess a unique characteristic. They can bend around islands and refract along coastlines. This phenomenon allows them to focus their immense energy in unexpected and often devastating ways, concentrating their destructive power in specific coastal areas that might otherwise seem protected. This complex behavior is precisely why modern tsunami warning systems rely on sophisticated real-time ocean buoys. These crucial instruments are strategically placed across the oceans to detect even the most subtle changes in water pressure, which can indicate the passage of a tsunami wave in deep water, providing vital early warnings. Tsunamis serve as a perfect and powerful example of just how intricately interconnected Earth's various systems truly are. They beautifully illustrate the profound relationship where the dynamic forces of geology, specifically the movement of tectonic plates, directly shape and influence the fundamental physics of our vast oceans. Consider the sheer scale. A relatively small movement of rock, perhaps only a few meters deep beneath the ocean floor, can initiate a chain reaction that ultimately displaces and sets in motion trillions of tons of water. This highlights the incredible leverage and power inherent in Earth's geological processes. Ultimately, the tsunami is the ocean's dramatic and powerful way of releasing the immense internal energy stored within our planet. It is a phenomenon that is sudden, incredibly powerful, and undeniably awe-inspiring, showcasing the raw, untamed forces of nature. So, the next time you gaze upon the calm, tranquil surface of the sea, take a moment to remember that beneath that serene exterior lies a hidden, immense force. This force is capable of spanning entire continents and unleashing unimaginable power, a constant reminder of Earth's dynamic nature. The fundamental physics governing a tsunami is elegantly simple yet profoundly powerful. When the Earth moves, the ocean responds with an undeniable and often overwhelming answer. It's a direct consequence of geological forces impacting the hydrosphere. Are you curious to explore more fascinating scientific phenomena and uncover the wonders of our world? Then be sure to subscribe and stay curious with SciCuriousID for more captivating insights into science and nature.
There's always more to discover. I'm Selu, and this has been SciCurious. Stay curious, and I'll see you in the next wonder.